I'm Anil Kumar, and here I have taken a very good example which will help you to understand how to sketch trigonometric functions when fractions are involved, right? So let's try to understand the question. It is sketch graph of function f of x equals to minus 2 over 3 sine of 2x minus pi by 4 plus 1. So let's first rewrite the function with factored inside part, which is minus 2 over 3 sine of, use square brackets, factor out 2, you get x minus pi by 8. So you can clearly now see that the function is translated pi by 8 units to the right. Now minus is reflection on the x-axis. 2 over 3 means vertically compressed by a factor of 2 over 3. The value of k is 2, that means horizontally compressed by a factor of half, so the time period is not 2 pi but pi. Minus pi by 8 is translated pi by 8 units left, 1 unit down. That's the vertical translation, right? So now from here, let's write down the characteristics which will help us to sketch the graph. So the first one is that it is a reflection on x-axis, right? And then we know amplitude is not 1 but 2 over 3. And what we know here is time period is 2 pi by k value of 2, which is pi. And this value, translation d equals to 1 and c equals to pi by 8 right. Okay, so all these things will help us to sketch the graph of the function. Now, since we have 1 up and then minus 2 over 3, what we will do here is kind of what is important for us to understand is the type of scale we should take, right? Whenever the fractions are involved, we should take scale which is easy for us to deal with. So what we will do is we'll take, let's say this is 1 for us, this is 2 for us, kind of, let me just go like this, and this is minus 1. Since we have 2/3, let me divide it into 3 equal parts. Do you see that? It helps, right? So everything is 1/3 now. Perfect. So this is 1 for us, this is 2 for us, this is 3. Then we have minus 1. The idea is to divide 1 into 3 equal parts so that we can incorporate amplitude of 2 over 3. Correct? Now let's begin. We have vertical translation of 1 unit. That means axis is at 1. So we'll draw a horizontal line here for the axis, which is at 1. Amplitude is 2 over 3. 2 over 3 means 1/3, 2/3. So somewhere here we will have our maximum, and 2 over 3, somewhere there we'll have minimum for this sine function. Perfect. Now my idea is always to sketch it in 2 parts. So the first function which I am going to sketch is going to be without horizontal translation, right? So I'll sketch a function g of x which will be minus 2 over 3 sine of 2x plus 1. Okay, so this is my function, and from here I will sketch f of x which will be g of x translated pi by 8 right. Do you understand? So this is my strategy to sketch. So let us sketch the function g of x. Okay, now g of x is minus 2 over 3 sine function. So normally the sine function will go up like this. Since it is reflected, my sine function will now be like this. Okay, so this is my sine function. Do you understand? Kind of like this. Do you see that? Now this is my first period. So from here I know that is, this is the value 0. This value, the end of the cycle, will be at the time period of pi. So that is pi for us, and this happens to be at half of this, which is pi by 2. This will be at half of this, pi by 4, and that peak has to be at 3 pi by 4. Perfect. So that is how we get our scale, right? I always make it later. So with that, I have sketched g of x. Do you see that? Without any horizontal translation. That is g of x. Now we will do f of x, and the only difference is f of x is translation of g of x horizontally by pi by 8. So where is pi by 8 for us? Pi by 4 is this much, and that is pi by 8. Do you see that? So every point moves by this much unit, right? So that point will be here, this point will be here, this point will be here, this point will be there, this point will be there, kind of. Do you see that? Ending here. So if I join them, I got my answer. Do you see that? So it is going to end here at pi plus pi by 8, which is 9 pi by 8. Okay? And start at pi by 8. Do you see that? That is how we will sketch these kinds of functions. So whenever there are fractions involved, use appropriate scale to incorporate them. You'll get very accurate graphs. So if you do all this on your graph paper, you'll get a perfect sine curve. I hope that brings us to a good position where you understand exactly how to sketch transform trigonometric functions. You can subscribe and learn a lot from my videos. Thank you and all the best.